Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll solve a problem on orifice meter. In our last video, we have derived the orifice meter derivation and there we found some discharge equation from that. And now we'll solve a problem on that orifice meter. An orifice meter with a diameter 10 centimeter inserted in a pipe 20 centimeter diameter. So see, pipe diameter will be more and orifice diameter will be always less. The pressure gauge is fitted upstream and downstream of the orifice meter and gives a reading of 19.62 Newton per centimeter square and 9.81 Newton per centimeter square respectively. This is the pressure value. Coefficient discharge of the orifice meter is given 0.6. Find the discharge of water through the pipe. We need to find out the discharge. So very simple. I'll directly go for the solution. So we know that Q equal to, we got the equation, that is CD. If you remember the equation, CD A1 A0 and root over of A1 square minus A0 square and root over of 2GS. This is our formula. And what are the data given here? If you see, orifice diameter given D0, that is 10 centimeter. So we can find out immediately what is the value of A0. And A0 is nothing but 5 by 4 D0 square. This is one. And if you see the pipe diameter is given, that is D1 is given, that is 20 centimeter. So immediately you can calculate D1 equal to this one. So A1 equal to 5 by 4 D1 square. Okay. And now this two pressure 1, pressure 2 value given. So I can write this is P1 19.62 Newton per centimeter square. So you can write this in meter square, that is 19.62 into 10 to the power 4 Newton per meter square. Similarly, we can calculate the value of P2, that is given 9.81 Newton per centimeter square, and this also we can write 9.81 Newton per meter square into 10 to the power 4 actually. Yeah. So all these values are given. Now what I'll do here, here if you see coefficient of discharge value given, so let me write CD, that is 0.6. In this equation, which value is unknown to me? CD is given, A0 I can find out here, A1 I can find out here, 2 value known, G is constant, H, only the H term is not given here, so that I need to be find out from here. Okay, so we know that H equal to the differential head, that is nothing but P1 by rho G minus P2 by rho G. This is came from the Bernoulli's equation also. Okay, during the derivations I have told this one. Okay, so now we need to find out the P1 by rho G. P1 by rho G. So let's calculate here. P1 by rho G. P1 equal to how much? 19.62 into 10 to the power 4 divided by 1000 into 9.81. Correct. So here if you get mostly we get very simple 9.81 double of this, so we'll get 1030 cancel, only 1010 into 2, that is nothing but 20. So this is 20 meter. Similarly, you can get P2 by rho G. This is again simple one, 9.81 given into 10 to the power 4. Similarly here 1000 into 9.81. So here we'll get 10 meter because 9.89 cancel, 30 cancel, only 10 will be there, that is 10. Okay, so we got these two values here. Now, so I can write 20 minus 10. So this is nothing but 10 meter of water. This is H. Now I'll just put all this value in this equation. So I can get Q equal to CD 0.6 into A0. A0 we need to find out here. We'll find out with the help of this calculator here. So that is nothing but 3.14 into 10 centimeter is given here. So that is 100 divided by 4. 314, sorry. 314 divided by 4, 78.5. So I can write 78.5, and this is root over of this one. This will get again, let's find out next one by 20. So that will be 420 square into 3.14 and divided by 4, 314. So here I'll get 314 square minus 78.5 square, and root over of 2 into 9.81 into h, that is all these things are taken in centimeter, so this also let take centimeter, that is 1000. Okay, now if you solve this value, we will get the value of discharge. So let me solve it one by one, need to be solved actually. So first things 0.6 into 78.5 into 314, 14,789. 14,789. Okay. Next 314 square and minus bracket start 78.5 square, get then root over of this. No. Okay, one by one I'll do, otherwise 314 square, how much? 98,596. 596 minus of this root over, then I can write what is that, 78.5 square, 6162. 6162.25, I hope. Yeah, and remaining things as usual again, root over of, this is 0, root over of 2 into 9.81 into, this is 1000, 2981. No, it won't get this much. Okay, somewhere we did mistakes. Let's do it like this, into 1000. 19,620. Root over of this will get 140. Yeah, this is correct. 140 point some value. Okay. Anyway, and then finally this one into 14,789. So 20 lakhs 71,000. 71,516 divided by, we'll get the equation of this. Next we'll get 98,596 minus 6162.25 root over of this 304. 304 some value, I am just ignoring that value. Okay, we'll get some point 71516 divided by 304. Yeah, 6814.19. So this is the discharge, centimeter cube per second. Now we can write this Q equal to 61.14 liter per second. This is our answer. So the same thing, discharge of water. So I have found finally the discharge of water from in this pipe. I hope you understood. If you are having any doubt regarding this, you can give a comment on the comment box. Thank you.